Hey everybody, it's Carpo, and it's a little dark out here, but I do my video. Fall has arrived. Now this video will not come as any surprise to those of you who have taken biology or study humans or human anatomy or chemistry. This is more for the layman, people like myself who are perhaps not too aware of how the body uses nutrients or exactly what nutrients are and elements. And I just wanted to point out a few basic things. And I had taken some notes here, so not all this is off the top of my head, but I'm very fascinated with the idea of how elements function. And I think that the average person, because I grew up with my own view of what elements were, what metals were, and I think that I probably share many similar views with a lot of other people in the way that I see things. Just because that's just kind of how humans are. So I was hoping to clarify a few things that might, open people up to some pretty amazing, things in my mind that I've always wanted to kind of understand how the human body uses these nutrients and these elements, rather. Not nutrients, sorry. And so the ones that they call it CHOPS, right? I think I got these ones written down. This is the standard elements, the 6 elements that supposedly the human body needs to survive. There's calcium, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Now, of course, that's not the only nutrients we need. In fact, a lot of people would leave out phosphorus or leave out sulfur and put in calcium. So I'm not here to argue the point, and I really don't care. That's not what I'm here to make a video about. It's about some of the interesting facts that are behind these. Now we have the oxygen, nitrogen, carbon, the building block of all life, right? Carbon is what it is. We have hydrogen, oxygen, and nitrogen. 3 gases. These gases in various forms and various compounds give us everything we have. And chlorine gas, let's say, if you mix chlorine gas, which is super toxic, and you mix that with sodium, you spray chlorine gas on sodium, you get sodium chloride, which is table salt. And so you can take toxic substances, mix them together. What happens is some of these atoms, some of these elements, the atomic structure has missing electrons in the ring, in the outer ring. So what it'll be doing is constantly seeking to take an electron from something else. This is why chlorine gas is so dangerous, because when you inhale it, it will literally rob an electron from the moisture in your lungs and convert it into sulfuric acid, I believe, or chlorine. Fuck, I don't even know. Anyway, there's some very detailed ways that these things work, and they're far too complicated for me to lay out here, because I don't even understand how a lot of them work. But there's chemical like fluorine, for example. Fluorine, or fluoride, which is from fluorine, we could say that the only thing that it's been found to do for the humans is to strengthen the teeth and the enamel. So far, perhaps it has other functions. Then there's the opportunistic elements, which when they're present, the body will actually utilize them for certain things and readily use them. But when they're not available, it's not detrimental or doesn't cause any problems to the human. So it leads me to believe that humans are fully adapting to whatever types of nutrients are available to us to an extent. We have to have the basics. The thing I found interesting about phosphorus is one of the basic building blocks. We got past the gases and carbon, but we have the phosphorus and the sulfur. Now, sulfur is well known. Sulfur is considered to be the brimstone, fire and brimstone. Okay, phosphorus is a glowing light. It causes a glowing. Phosphorus, when it burns, it creates that phosphorescent glow. And the interesting thing it got me thinking about is that it was originally, I believe, let's take gold for example. Okay, we got phosphorus, which is basically this glow. It was taken from the Luciferian context. It was named after the Lucifer. So phosphorus, the glow, Lucifer, the light, right? The light bearer. It was really interesting stuff considering you've got sulfur right next to it. What was the other one? Oh, sorry. This one that I also wrote down, which wasn't on some of the other charts, which was selenium. And selenium is a nutrient that's used for DNA, RNA production, as well as cell production. And the interesting thing about selenium is that it's derived from Greek word selene, which is the moon. So there we are. We have the moon, and we have the sun, and we have fire and brimstone. All these things within just 3 major elements that the body needs. So you start to break this down further, and you start thinking, okay, how many of these archetypes, that we've been able to finally pull out of the woodwork, out of the books, the great books that were written, and the great studies that have been done, and to say, oh, these are symbols, perhaps even deeper than we think. I mean, this isn't new, of course, nutrients, the elements in the body have been well known, for a long time. But this is my recent study, and this is what I'm involved in, and I'm sure there's someone who's taken this to the next level, to way beyond, anything, and I'm always looking for that person. Okay, arsenic is a good example. Arsenic's required for human growth. It's required in small amounts for mammals, as far as, well, it may not be required, but it's utilized. And it is required for some mammals for, what was it? No, it doesn't say what it was required for, but of course we know in large doses it's toxic and it will kill you. Everything in small doses, right? Well, the periodic table of the elements, I believe it's over 70% of it is metals, They're all metals. Calcium is a metal. And phosphorus is a metal. These are all soft metals. They're not what we consider metal. You couldn't make something out of them. But when you realize that all of these metals on the periodic table, which make up almost everything, are actually crystals, that's when it really starts to take a turn. Because, I think that everyone that I've ever met views crystals with the kind of idea that a crystal is a clear or glass-like substance. That's the property that it holds. Perhaps atoms are aligned a certain way, but a crystal is usually thought of as a crystal. I think that most people picture a crystal. When they think of a crystalline structure, they think of maybe intricate crystals. But the whole idea is that a crystalline structure is aligned atoms. It has atomically arranged grid system. So, for example, people who make certain, like bells. So I was watching this documentary where they were making bells, and you have to mix, I believe it's 80% copper, 20% tin to get bronze, and that's how you get that tone. You can't do it with just tin. It doesn't work. You can't get the right tone. You can't do it with just bronze, with just copper, because it's too soft and it'll fall apart. This perfect balance is what's needed. So these people took actually a chunk of this bell to the lab, to a laboratory, and had it analyzed. And lo and behold, when they put it under an electron microscope and looked down at the atomic structure, it appeared as rows, as grids. See, this isn't, when metals are mixed, they don't just, it's not just a bunch of randomly arranged atoms, which is, I think, what the general population may think, if they think about that at all. The atoms are just kind of all packed in there, but when you mix these metals, they arrange themselves, and the tin atoms put themselves between the copper atoms and stop them from vibrating so much, which is what keeps it from denting. So it's not necessarily even the hardness of the metals mixed, it's how they react together. The atomic world is amazing. So there's this big row of tin atoms, then 2 rows of, 3 rows of copper atoms, then a row of tin atoms. You even look at it closer, and it's a patchwork. It looks like a quilt. And when you're looking at these atoms under a microscope, if you think a step further to realize that these are just really fastly moving electrons spinning around a nucleus, then you realize that these are all little balls of light that are arranged in a grid pattern. And what is light that's arranged in a pattern? It's a hologram. It's a hologram. And so when people go around talking about how the world's a hologram, the universe is a hologram, everything's, an illusion, you have to have some sort of an understanding of what that means, and you have to back that up. So that's what I'm doing. If I'm going to say the world's an illusion, I at least have to know what an illusion really is. Well, yeah, an illusion would be quadrillions of little balls of light all interplaying together in this perfect little dance. But the fact that our body is utilizing these certain nutrients that were, elements that were named after astral bodies, or the moon, the sun, the earth, Venus, Saturn, it makes one wonder exactly what these things are. What are elements? I mean, it's pretty crazy stuff. Let's see if I have any more notes on here. No, I just had a few things written down there. So, take from it what you will. I mean, I'm not here trying to teach anybody anything about the human body by any means. I'm just trying to understand how we utilize these things that don't exist, these invisible little... Yeah, it's pretty weird. Sorry, I've been wanting to do that all night. So what do we got? We have... Oh, I'm sorry. Sorry for the pause. I had to remember what I was going to talk about. Gold. Gold is that element, that one, that, like they say, has brought so much happiness and so much destruction. And I know a lot of folks may think that gold is just pretty, which it is, but gold is an amazing compound. It is the most malleable metal. I mean, this is why they used it for wrapping everything. It can be flattened out. 1 ounce of gold, I think, could be flattened out to like a swimming pool size or something. It's pretty intense when you're making gold foil. You can get probably even more than that. Anyway, the chemical symbol, on the element, on the periodic table of the elements for gold is AU. And I have often wondered, because my neighbor has a license plate, and it's AUELOX. And I asked my neighbor one time, I was like, so is that Goldilocks? She's like, you're the first person that's ever figured that out. And AUELOX. Yeah, it's 2 separate words. AUELOX. So it sounds kind of French or whatnot. But she has... anyway, she sorry, spacing out. It's getting late. She said that was the first person to actually, call that. And so I'd been wondering, what the hell is AU? That's gold. But I never really thought about why. Why not GO or GD or whatever? Turns out that gold, the term AU is actually derived from aura, or the aura, the light. And so gold is aura. And so it makes me wonder how these metals interact with our body. Maybe gold has something more to offer than we know. I've heard people say gold is important for this or for that, that it helps us connect with our higher selves. So many different things that I've heard, and that they spray it in the atmosphere in Nibiru to keep their planet from, going into burnout mode or whatever it may be. But maybe gold has a much more benign use, something just so much more subtle that we can't quite understand it. There's many forms of gold. There's a lot of talk now about monatomic gold, which was believed to be, taken from, I believe, the Mediterranean Sea or somewhere over there. But monatomic gold is a different form that's more readily available for the body. But before I forget, I just wanted to say that crystals, the idea of crystals, so I was going to say is that metals are crystals. Metals are crystals, a different form of crystal. So when you see a piece of metal in its raw form, know that that's actually a crystal. If you are into like magnetite and certain metals that come in strange forms, they will grow just like a crystal. I mean, I have some rocks that are like, they look like plants. I mean, these are rocks that grow, metal rocks that grow like plants. And I was always fascinated to learn that aluminum doesn't occur anywhere in chunk form, but it occurs naturally everywhere and makes up 7% of the Earth's crust by weight. 7%. And you can grab a handful of dirt, break it into 7 piles, and one pile of that is aluminum. That's a lot, but you can't see it. And so here we are with all these metals, and I think it's pretty fascinating to realize that just about every compound out there has metals in it. Everything you can see around you has metals in it. Wood has metals in it. The tree used wood to produce itself. There are very few things that aren't utilizing crystal structures. Now, I'm pretty fascinated with crystal structure. I mean, it's awesome, the way things grow. I mean, every kid in his class may have done those salt things, where the sugar on the stick. Anyway, that's some good stuff. You can learn a lot from the way crystals grow, but I'm done for now, so peace.